To put that simply, we support entrepreneurs and ventures at every step of the entrepreneurial journey. If you'd like to engage with our venture growth team, read stories about innovation that is shaping our community with world-changing ideas, or join other upcoming experiences, I invite you to subscribe to our newsletter using the link in the chat. Acknowledging the stolen land upon which Tech Alliance sits is merely a starting point. As settlers, it is imperative to honor the region's First Nations and all the original peoples of Turtle Island, to recognize the trauma, genocide, and history of Indigenous peoples. This land is the traditional territory of the Anishinaabe, the Haudenosaunee, the Lenape, the Attawandaron, and the Wendat. To advance truth and reconciliation, our team is committed to continued learning, advocacy, and actively working alongside Indigenous-led businesses and entrepreneurs. Before we get the fireside chat started, I have a few housekeeping points. For those of you joining virtually, please know that your mics are muted throughout the event, but please join the conversation by adding your questions in the Q&A feature at the bottom of the screen and any comments in our active chat feature. For those of you here in the room, we will have an opportunity to ask questions at the end. Also, no need to take notes. For your convenience, this event will be recorded and available for replay on our YouTube channel. For those joining us virtually, let's get the conversation started. Tell us what you're interested in learning about with regards to robotics and drop it in the chat. Today, we have the chance to dive into the endless possibilities of innovation by way of robotics. Whether you're new to automation as an idea, or in the midst of integrating robotics into your business, or robotics is already an integral part of your day-to-day, I can say with confidence that this discussion will be both interesting and eye-opening. Now, I have the distinct pleasure of introducing a panel of experts, Jim Beretta, Chuck Baresich, and Konrad, three thought leaders in the robotics space and in our community. Jim Beretta is the president of Customer Attraction, a London-based marketing consultancy serving advanced manufacturing, robotics, and automation. Jim works with technology companies across North America to position and build brands and drive sales growth using bold approaches to marketing and market leadership. Jim is also the host of the Robotic Industry Podcast and a speaker on topics including automation, robotics, marketing, social, and digital marketing strategy. Chuck Baresich is the general manager of Haggerty Limited and Haggerty AgRobotics Company. Using a solution-based approach through his work at Haggerty Creek, Chuck brings advanced technology to agricultural producers. Skilled in negotiation, agronomy, business planning, customer service, and agribusiness, Chuck has a demonstrated history of working in the food production industry. Konrad is the founder and president of KONNEXIO Inc., a London-based custom automation and robotics company that creates pre-engineered and standardized platforms that serve as base systems for customer-centric industrial and greenhouse automation solutions. Konrad is also the chair of the board of Tech Alliance, where he leads the strategic oversight of a vibrant technology sector, supporting the startup, scaling, and technology exchange of tech companies in Southwestern Ontario. Tapping into the expertise and years of experience in the robotics industry that this panel presents a unique opportunity to explore robotics development, applications, implementation, and distribution that will help you get to understand automation to support your ventures. Now, let's get at it. Here are my questions. Often when discussing robotics, the idea of jobs comes up and where do humans fit in the future? Jim, can you tackle this one right off the bat?
I'm going to be passing this right over here.
Thanks, guys. Yeah, that's an interesting. Well, first of all, thank you everybody for coming, and it's a pleasure to be here today. So yes, that's an interesting question. We used to hear that much more in the past. To be quite honest, it's being less and less of an issue, and it's been specifically not being asked very often anymore in the last 2 years, I would say. We're struggling more with the opposite, actually, that we don't have enough labor nowadays to support our endeavors in production and manufacturing. So that's the first part. The other part is that typically what we want to do is we want to upscale our manufacturing and our labor force. So people are still needed. It's not true that we're replacing them. We're just kind of changing their requirements, and we're actually upscaling them. They're becoming much more qualified in what they do for us or do for the manufacturing. And it's going away from just a simple autonomous repetitive work, but more so of actually handling, making decisions on the system right away. So I think the workplace really changes, and most people actually recognizing this, that they actually need automation and they're not really fearful of it anymore. And I think, Chuck, you had some ideas towards that too.
I think in the ag space, building on what Konrad had just talked about, there are lots of jobs that people just don't want to do. And it's almost unfair to ask them to do. You know, it's one thing to sit there and say, you know, Canadian workers don't want to go and hoe weeds. But when you actually look at what the conditions are like, where it's 35 degrees, it's hot, sunny, and dry, is it actually, does anybody want to do that, honestly? And it's just a job that, you know, automation has a good fit for. The interesting flip side to this argument is I have customers coming to me hoping to get rid of employees, and I tell them that they can't. I said it's very, very hard to replace the human supercomputer that's sitting on the tractor. There's a lot of skills that come in that robots are quite dumb, and they don't know what to do. They don't even know if they should get to the field in the first place. So there's going to be no magic snapping your fingers and eliminating employees with robotics. That's not really the answer. And upskilling your employees and changing what they do is what robotics is going to enable them. And I think if you look within ag, you know, there's been fewer and fewer and fewer farmers with every generation, and that's because of automation technology that's already been happening. So.
Awesome, thanks. What are some of the current trends in the robotics industry? And I'll start with your.
I think there's lots of interest in agricultural robotics. I think there's a need or a trend or a push to change how food is being produced. One of the things that's driven this is bringing the consumer closer to the farmer. You know, so if you think about 100-mile market, or if you think about a market gardener, if you know, bringing consumers back to actual food production, sometimes when consumers see how that food is produced, they're not used to that and they may not like it. So a farmer might, you know, as a farmer, if I put that hat on, I fully understand why I put fertilizer and why I use Roundup and why I use glyphosate. It makes perfect sense to me. But to someone who is not from the industry, that it's not as clear to them, and they don't necessarily like it. And it would be the same for me if I went to a school or to a hospital or whatever. I don't know how those businesses are run, and I question things. And so the consumer is also telling the farmers, though, that they'll pay more if you omit certain practices. But a lot of that relates to, it requires more labor. So I think this is driving a push for, more processing vegetables, more vegetable production, more high value crops in ag. That requires more labor. In return, we need more robotics to make that labor happen. So I think there's just been an explosion in the last 5 years in the robotic space, whether it's for weed control, harvesting, tillage, planting. There's just been an explosion in that space.
Thank you. So when we look at what's happening in the robotics industry, we're seeing a lot of really interesting things. First off, we're seeing a lot of innovation. We're seeing a lot of startups. We're seeing a lot of interesting new companies that are developing technologies that we're going to be able to use in our factories, because I'm going to talk more about factories. We're seeing more robots. So we're seeing more robots everywhere. We're seeing more companies, more OEMs, they call them original equipment manufacturing companies, that are building user-specific robots. So maybe it's a robot that's specifically made for welding. Well, it's going to be slightly different than a robot that's being made to unload a mold machine. We're seeing also, although albeit a very small percentage of robots, maybe 3, maybe 4%, are collaborative robots. And these are robots that people can work beside. So what we're seeing, though, too, in collaborative robots is we're seeing companies that are opening up their API. That means that other software companies can actually put code into the robots and can put accessories onto the robots. So what that's doing, it's pushing the OEMs into building more and more innovative robots. So I think we're going to see more robots. We're going to see more vision. We're going to see more specialization within the robot industry. And I'll pass this to you.
Yeah, no, I fully agree with the cobot and other areas that are much more components are coming in the automation industries. They can be used by integrators or even completely complete turnkey systems that can be used for certain tasks, like in ag or like in other areas, for example.
Awesome. Jim, how does Canada rank on the world stage in robotics, vision, and automation, and why?
So, you know what, I think Canada is we've got a really, really good technology community here in Canada. And there's a bunch of reasons for that. And I think that's a bunch of people come over from Europe and started right into working in the automation industry, working for automotive, working in plastics molding. So we've had a lot of really big successes. And even locally, we have some, but I think we're going to talk about that in a minute. But I think we punched way above our weight in building automation systems, especially vision guided automation systems. And of course, Canada is a net exporter, right? We're an export nation. So we export automation all over the world. What we don't do, which I hope we get a chance to talk about, is to see more and more of our North American manufacturers installing automation and using automation, investing in STEM, investing in our schools and putting robots into schools. And that's one of my personal things that I'd like to see more and more of. And maybe we'll hear about automation on farms now.
Well, I think, Canada, we're very quick to adopt the technology in the agricultural space. I think one of the things that I see as a bit of a disappointment is often farmers will look overseas, first. They'll go to Europe first. They'll go and they'll see something that has been built. And I think part of that is that some of the infrastructure work that was done in the ag space started 4 or 5 years ago. They started a bit sooner. The regulations forced it sooner, whatever reasons there are. And it isn't that we don't have the people. So one of the things that I see looking around is that we have this, we have the institutions, the universities, the schools. We have a very strong automotive and manufacturing sector here in Ontario that, and to be honest with you, there's not a huge leap to go from a self-driving car to a self-driving tractor. A lot of that technology is the same. And similarly, there's a huge, there's lots of crossover between a factory and a warehouse and a cucumber greenhouse or a dairy barn or whatever. There's lots of crossover there. And so what I would like to see here for Canada to step it up a little bit further is to actually see more of that innovation with a made in Canada stamp, invented in Canada stamp, get it out of the universities and commercialized, which I think is what you guys are.
Yeah, thanks. So focusing on London, Konrad, how important is automation and robotics to London and the surrounding area?
Well, I think it's very important. We have a lot of manufacturing here in London as well, although a lot of the manufacturing here is either food processing, injection molding. There's a few automotive parts manufacturer. So some of, especially on the food processing and the injection molding, they usually employ a lot of specialized machinery that's dedicated for those industries. Nevertheless, we have quite a few very good machine builders and very good automation companies here locally, besides us, not just ourselves. But they're really doing an excellent job, and we're serving a lot of market all over North America. Coming back a little bit to the other question from before, and for Canadian companies in general, I think it applies also to London, is I think Canada is really good in building turnkey systems or complete automation system. I think one area where we could improve on, and even London as well, is building more like dedicated products as a final solution. I think that's where we're not really all that great. We tend to integrate other people's components, other people's systems into ours, but we're not really all that great yet in developing our own products that we can deploy all over the world, basically. And that's an area where I think we could do better.
I'm going to add a little bit to that because having moved from Cambridge, Ontario, which in Canada is one of the leading places where automation's built. We've got a lot of robot companies there in Kitchener, Waterloo, Cambridge. And one of the things when I moved here, I'm looking around, I'm going, wow, we've got companies like KONNEXIO, we've got JMP, we've got Armo, we've got lots and lots of other machine builders and automation companies here. So I think I'm going to put a little note in that we should be better at marketing our capabilities in the automation sector, because like London, who knew, right? And of course, I've known you for like 30 years and known that you've been here, but I think there's a little bit more work that we can do. And I did want to put a point into Montreal. Montreal is also a very high-tech place, and Montreal's kind of between robotics and artificial intelligence. Montreal has got companies like Mechademic, they've got Vention, we've got Kinova making robots, so they're OEMing robots there. So, and I think this goes back to some of the government's early investments into universities and in that commercialization.
And also AI over in that area as well. Yeah. Chuck, let's talk about safety when incorporating robotics into your venture. How much of a factor does regulation play when working with robotics and automation?
That's a great loaded question. And actually building on Jim's point, we're actually working with two companies from Montreal that are, and now to say it, both of them are involved strongly with AI in their robotics function. So that actually builds right into your point. When it comes to safety, in the agricultural robotics space, it's the Wild West right now. As it stands, there really aren't any rules governing what is happening with agricultural robotics, especially out in the field. There might be some in indoors, but we're more focused on the outdoor crop agriculture space. And safety for us, the way that we're looking at it, one of our robots weighs 18,000 pounds and drives 10 miles an hour. And so when that thing is charging across the field, it gets a tank. And I don't know that a semi truck would stop it. And so, that robot, when we first got it, it had no perception, no safety systems of any kind other than a tripwire. And so the robotics companies, what they're doing with us right now is they are focusing on having an operator present to monitor the machine. And that's how they are trying to incorporate some sort of stuff until the regulations come in. So as a company, what we've been doing for the last year is we've been documenting our experiences with the different machines, and we've been having meetings with the local fire departments. What do you do when a lithium phosphate robot is on fire in the field? Who can approach it? All these kinds of questions. And so we've been trying to document these things to go back to the manufacturers with some safety protocols, before an accident does happen. But yeah, it's kind of the Wild West right now. We are very concerned because nobody wants to be the first YouTube video or Twitter. Agriculture uses a lot of Twitter. The first Twitter video that shows a robot crashed into a pickup truck or that has hurt, or even worse, has seriously hurt somebody. And so those conversations come up. All kidding aside, we really want to make sure that no one gets hurt using these machines and sets us back.
Yeah, sure. We've been struggling with the same thing in the greenhouse, actually, that we're trying to find out exactly what regulations apply to greenhouses, and it's not really clear there either at the moment. So in that area, it's not fully clear at the moment. On the industrial side, of course, to safety, it's very simple. It's very clear cut, and it's a lot of experience in there. So automation systems for industrial, they typically are very, very safe in Canada. And a little bit different when you go to the US. You don't have the same regulation building into the US, but there it's mostly company driven, while here it's pretty much a process that you have to go through, like a PSR and electrical inspections and so on every equipment. So for industrial, they're really well, systems are very well designed.
I'm just going to add a little bit to that because I was kind of on the forefront of when collaborative robots just got started here in North America, and we were busting to make all these collaborative robots. And just for the people in the audience who may not know what a collaborative robot is, I'll explain it a little bit more. A collaborative robot is a robot that you can work right beside. if you touch it or it touches you or it touches some tooling, it will slow down and it will stop. So we can just say for simplicity's sake that they're implicitly safe and they will stop or slow down on their own. It's not that true. And there's end effector issues and, you know, all kinds of other things we have to talk about, but that's another fireside chat. So anyway, what happened when collaborative robots first came on the scene, again, it was wild, wild west. There were no rules, and there was about a 4-year gap between, in this case, the Robot Industry Association actually took some steps and created some, I think, very important specs. But I think there's also a lot of robots out there that may not be covered under some of those safety specs.
And I'm going to add, there's an opportunity in the entrepreneur tech space to build some of these safety systems to help these companies out. A lot of the engineers, they're so focused on getting the robot to drive straight. You know, they're worried about that. They're not worried about the overall safety. So there's an opening and an opportunity here for some bright Canadian people to work on that space.
I just want to tell you a little story because I think it's it fits right into this conversation. So we were up in maybe Stratford area, and we were going by an outside equipment dealer, like a lawn cutting equipment dealer, and there was a autonomous robot cutting the lawn. And I was like, "Ooh, I'll get some little Twitter stuff here. I'll go take my phone and I'll stand in front of the lawnmower so that the lawnmower will have to stop." No, lawnmower did not stop. And I thought, okay, great. It's going to look at me. It's got some LiDAR. It's got some kind of technology on top of the mower. It's going to recognize me as a human. No, it did not recognize me as a human. So that was a very short video clip.
Nice. Konrad, what other areas of robotics need more investment or attention, and where do you think one should look to for this?
I think that we need to have more systems that actually are dedicated products and solutions basically can do something. And like I said, we're very good in building customized systems, but I think we need to bring them more to a product stage where we're actually developing them and actually making a full functional product that can do something for a truck, for example, can do a certain task, complete it, and not being so custom built, so to say. We are trying to develop this on our side, for example, in the greenhouse, where we're trying to develop a robotics in the greenhouse that can do certain tasks as a product. And then, of course, we're trying to scale it then from there, rather than being a custom machine builder who goes to what happens is very often too, and correct me if I'm wrong, very often the farmer knows what he needs to do on the farm, but he doesn't know how robots would do it. So very often we're struggling because we are engineers. We're thinking like, I don't have no idea about what the farmers need necessarily, but we need to kind of find the way how to build products that actually serve them to actually complete certain tasks as an entirely. And we don't always understand this very well, and working together there more in those areas to develop those systems, I think would be greatly needed. On the industrial side, we're doing a lot of a pre-engineered system as well, where we have this idea where instead of building custom machines, we should have a platform that actually can be configured. Instead of trying to build every time a new machine and start from scratch, we rather would actually have a platform that can be programmed. And we have built a lot of functionality into our systems where we don't need to redevelop them every time new. We can actually program the different systems towards them. And makes the deployment much better. It makes them also much better products because we actually pre-engineer them. We actually have them built like 10, 20, 30, 50, 100 times. And now we know all the ins and outs. Because every custom machine and every custom robot, at the end of the day, is a prototype. And the prototype still has some flaws and some shortcomings and some programming issues, and some stuff is not always working 100%. And we can only solve this if you go into a product level.
Well, I think almost every robot that we use at our company is a prototype. You know, they say that they're commercial units, but they're not. And so I think in this space, you know, if we look at I'm going to look at Ontario specifically. You know, if Ontario is being looked at as a home for the movement of processing vegetables north, then some form of harvest aid is going to be key. So working on robots that can assist with harvesting and The other piece would be is looking at robots that can assist with disease detection and disease control. And don't come to me with another sensor that's going to do all these wonderful things, because most sensors don't do anything. You actually need to be able to detect something useful that the farmer is willing to pay for. I think that's another area of growth that needs work.
I think and both really good valid points. I think one of the things that we need to think about is that where is that big pain, right? We've got like crops that can't be picked, right? We're wasting food. What a silly thing for us to be doing in this day and age, especially right now when I talk to a lot of the people on my podcast. I'll put a plug in for that. We talk about the high mix, low volume or medium volume that's happening. So whatever people can do, and robots, of course, are invented to do the boring, dirty, dull, disgusting work that humans don't want to do or can't do, and certainly can't do 24 hours a day. So I think when you're looking at what do we need to do for robots, let's look at that pain and let's absolutely try to solve that pain.
There's lots of interest in growing pumpkins and watermelons. And guess what? They're heavy and they're on the ground.
Chuck, your comment about how sensors don't really do anything kind of leads into our next question, which is another aspect of automation is the data. So Jim, including the role of AI in robotics, how do you see them sort of playing together?
So you can both love and hate data. I'm in the I love data camp, but there's trillions of dollars of capital equipment that can't collect data. So a lot of times when you're out in a factory and you're saying, hey, listen, if you put this automation system in between the AI and the vision and the multitude of sensors we have, we are going to actually change the way that you're going to manufacture, which is great. But there's a lot of companies out there that also don't really want any intelligent data collection on the machine. They just want to run the machine and run it into the ground. I think Canada, we have this opportunity to absolutely collect data. We have the brains, and I don't know if they're Montreal or if they're Western University or where they are, but absolutely to take that data and mesh it with other data, other manufacturing data, and come up with some really, really interesting, cool tools.
Wow, I don't know. I'm indifferent to data, but of course, it can do a lot for you. We on the ag business side of it, for example, we partner with somebody who actually is more specialist on looking at those crop evaluation to understand, what is the health condition of a crop, what's the deficiencies that they need to put in there. We as a machine builder, we can't do everything. We have to find the right partners to do those kind of solutions. And I agree with you, a sensor doesn't give you anything. You need to build the algorithm and you need to feed it with enough data in order to understand, what does that mean? And that takes time. And that's usually something that you build over time. You have to have a good concept, how you're going to collect the data, what you're going to do it, but then you need to actually over time develop that. On the industrial side, for example, we also believe a lot in data, but here it comes back to what I said before. When you build a custom automation equipment and you have only like 6 or 9 months time to build some piece of equipment because the manufacturer wants to go ahead and produce, you don't have enough time to do all this. So again, what we're trying to do is we're trying to standardize our machinery, standardize the controls. Now we can actually build a data platform on top of that machine. And now we can actually start collecting data earlier because the functionality is very common now in our machines compared to a custom machine where everything is different, everything is new. You don't have the time to develop those things on a custom-based solution.
I think as I put my farmer hat back on, we're super interested in data. So I'm a data lover myself. I've always been involved in lists and data collection and trying to consolidate maps. And agriculture is an interesting space because we're finally at the point where we're working with ISO XML and very standardized components and ROS systems that we can start to actually not just collect the data, but layer it against each other. And as an example, I had one of my best corn crops ever at my home farm this year. It was 230 bushels to the acre. It's great. It's the best I've ever had. The theoretical yield of a corn plant in a greenhouse situation is like 1,800 or 1,600 or something like that. So I don't even know if I'm at 20% of theoretical yield. So even though we think we're doing a good job, we're not doing that good a job. And the promise of data and data collection is the per plant analysis of what's going on. And one of our hopes is with the automation of it and trying to automate data collection is that can we turn every farm into a test plot? Can we turn every tomato plant that gets seeded into its own test plot and figure out what conditions worked and what didn't work? Because that's how we're going to grow more food. And that's how we're on less acres. The reality is there's going to be more farmland paved over with houses. That's going to happen. It's happened for the last 1,000 years. It's going to keep happening. We need to grow more food on less land, and that's data is going to generate that. The challenge we've had is that tech companies have come to us without the AI and the algorithms and trying to get us to write a check for something that doesn't add any value. And we need to spend some time and some investment to say on the so what, how do we take this information and then so what can I do with it? And as farmers, we need predictive data. That's actually what we require. What do I need to be doing in 2 weeks? Reactive data for us is pointless because it's too late by the time we get it.
Nice. Anticipating what the audience might be looking to learn, can you all share a few tips and tricks for those of us who are thinking about incorporating automation into their business?
So I think one of the things that I would recommend to people who are looking to do automation is to plan early. Like give yourself some of that extra time, and also do yourself a favor and take some of the really hard stuff off the table. So if AI is really important to you, if vision controlled robotics is really important, if you're trying to do something you've never done before, pay some money or partner with a company and prove out that automation, give it to your machine builder, and then your machine builder doesn't have to, or maybe it's a project, and maybe KONNEXIO does this project for you, and now they've taken that risk off the table. So de-risk and do lots of planning and start early.
Yeah, no, I fully agree with that. We do a lot of prototyping before we actually go ahead and actually build a full system out of it. On top of that, what I would also recommend is to modularize your equipment. And I've seen this many times where we build a piece of equipment, customers thought they know exactly what they wanted until we were half a year into the project, and then they found out, no, we now need to add this operation to it, and this system is not there yet. And it was never discussed and never was thought of in the beginning. So modularized machine building means that you actually have the option to actually change those things still, to add more components towards that. I think that's a very important aspect that I would recommend. And then also, don't try and predict the future. We don't know if volumes, I mean, obviously marketing always tells you, okay, we're going to start with this volume and the volume's going to go up and up and up. And then sometimes they don't. So over engineering your systems and making the systems too high production volumes may not be good for you in the long run. So plan with what you have right now at the moment, but allow your system to actually be able to adapt and to increase production, increase automation levels, increase productivity on the machine over time. That's usually the best thing, because a machine builder typically has only 6, 9 months, maybe 12 months on a really large system to spend with the machine. You need to make sure you get a piece of equipment that is easy to operate, is easy to maintain and service, and then you can start implementing improvements and make the machine faster and better over time. And at the end of the day, every machine builder, every customer has learned this, that the machine never comes to you as 100%. It comes to you as an 80%. And then from there, you now can tweak it in to make it better.
I like your comment. I know one of the manufacturers that's built us a couple of custom robots. The second robot I told him to throw his welder away. I said, do not, make sure that we can take this thing apart and reconfigure it, because it's too challenging. In our world, what I've been telling our growers is that they really need to sit down and understand their farming operation. Farmers have generational intelligence. They've been doing the same thing for the way their grandfather did it. And so when you stop and you ask them, well, how deep should you cultivate for these weeds? They don't actually know, because they just go out there and they just do it. So how do you bring a robot in there into their operation without them actually understanding what their operation is. And I think Jim touched on this about, you break down your tasks into very, very as small of individual pieces as you can, and then give the robot, maybe not the simplest ones, but the simplest ones to understand and be able to tell someone else how to do. Don't I get, don't give the robot challenges that even a human has a hard time meeting. Try to compartmentalize it, break it down, componentize it, whatever. And that'll give you your greatest chance of success. Not only as, integrating robots into your operation, but if you're a manufacturer trying to sell a robot to a farmer, you can say, I can do that with 98% success. You're going to get a lot further.
Great. Looking to the future of robotics, what do we have to do to grow this category? How do we entice the next generation? And how do we get our kids involved in this industry? Anybody want to take that one?
So I think one of the, let's get them started early. I think that's probably the most important thing. And where you say, great, we'll do this in high school. No, let's do this in grade school. Let's get kids these Lego Robo kits. Let's support STEM. Let's open up our factories. Let's give them tours of our robot integration businesses. And I think getting people really excited about what that next step for them looks like is probably the most important thing. Also, if we're going to engage with the schools, let's pay for the buses. Let's get the teachers the tools that they need to do to get kids excited about robots and automation. And I hope we talk about some of the other things that we can do even locally and maybe another piece.
No, I agree. There's lots of options and opportunities to bring more people in, especially young people. As a matter of fact, we have found that a lot of the students we bring in as internships or as summer students, they actually are very well trained. They know a lot, and they even can help our team still improve, and be very productive in what they do, actually. I think it has changed a little bit. I mean, when I started the business 20 years ago, can't believe it's 20 years now, it used to be not very popular, automation. It used to be like, who wants to do that? But it has really changed a lot. Nowadays, it's much more engaging, the industries. We used to employ 10 mechanical design engineers and maybe one programmer, one controls engineer kind of a thing. And it used to be all design. It used to be just work on CAD and used to be very static. And this has all changed a lot, actually. Now we're employing basically, 2 mechanical engineers because mechanics have really gotten simpler because everything is programmable now. So we're putting a mode in what we used to do a lot of pneumatics in the past and point-to-point kind of a thing, I/O kind of a thing, simple controls are now simple mechanics because you put a motor on everything and you tell the programmers make it work. And very often the programmers say, well, how am I supposed to do this? It's not even designed properly sometimes. But now we are employing 2 mechanical design engineers and have 10 controls engineers and our robotics engineers for that. So it really has changed a lot. And that is really a work that young people feel much, much more engaged in than the mechanical CAD work and so on. Still, some people like it, thank God, because we need them. But I think it has changed a lot and it's much, much more attractive nowadays, what I have found.
I think for building the marketplace, showing that this automation is out there encourages people to go into industries where the automation is required, which in turn instills demand for those products. So if you think about a young generation that watched their parents milking dairy cows 3 times a day, 7 days a week, to now going out and having a robotic milker going to do that, the younger generation looks at that and they see 2 things, and they say, 1, I don't mind being a dairy farmer anymore because I don't have to go and do that every day. And 2, when I go to school and I learn some stuff, I'm not going to go and necessarily just learn how to make feed rations and learn about, body mass index and somatic cell counts and all this kind of stuff. Maybe I can go through, and I'm more interested in learning how a PLC works and learning how a computer programmer works. I'm interested in that. I can do that work and still be a farmer. And those two used to be exclusive, and they're not exclusive anymore. So showing people at some stage of the game that these two things can interconnect is I think useful. And I know, like, my daughter, when I first had them all playing with our Arduino kits in the house, she didn't understand what was happening, but when she was able to make the light bulbs turn on and everything through the computer code, she thought that was pretty fun. And she still talks about that. And so part of this is trying to understand you can do these things and it can be done here locally. It is a career path. It's a way to grow the space.
And outcomes for, I think your dairy farm example are a lot better for the animals as well, because you go from, maybe you could milk 2 to 3 times a day, and sometimes the animal would be a little uncomfortable with that. And now they can walk into a carousel and milk themselves essentially. So that's great. Now, to pull out the crystal ball, supply chain has been greatly impacted the last 2 years. How has this been seen in the machine building and automation integration industry? And what do you think the future holds in terms of supply issues? See you laughing.
Yeah, I think we are almost a full year behind where we had hoped we'd want to be in our limited scope that we're doing, just by lack of supply. The manufacturers can't get certain components. They can't commit. When, the one robot that we were hoping to have. So one of the things that we're doing with our company is building implements for these robotic systems so that they actually do something. But we couldn't start building the implement because the robot is arriving on December the 10th. It was supposed to come on May the 5th. And obviously, you know what weather's like here in Ontario in December. So it's put us a year behind. And so it's hard to commit to anything. It's also been difficult to try to find funding projects and commit to these projects because of that. So that's a challenge. And hopefully things will pick up shortly.
So I'm not a machine builder, but I'm going to pass this to a machine builder in a minute. But what's really been interesting about the supply chain catastrophe that we've had, especially in the automation industry, is that we've really learned to be resilient. So maybe you're using old robots, like refurbing robots. Maybe your customer now has changed and he's not going to use an Allen Bradley PLC. He's going to use a Omron PLC. And so what's happened now is a lot of manufacturers have had to absolutely change their rules and their regs. And we've had to become very creative in looking for stuff on Kijiji or whatever, right? eBay, to find those chipsets that you need. So anyway, you can tell the real story.
No, you're absolutely right about what you're saying. That's the problem. We're buying stuff now on Amazon and on eBay, which you never in the past have ever done before. But yeah, it's been really, really painful. I mean, when you have you on the customer side, more or less, where you're trying to employ those robotics, it's very difficult, but we have to also disappoint our customers. They come to me and some understand and some are a little bit more understanding and some are not. And for them, and for us, what it takes a lot of it's also a big issue about cash flow, because if I cannot ship and deliver a piece of equipment, fine, the customer may not be too upset about this, but I still cannot invoice. I still cannot, proceed with the project. It's very, very difficult right now. So we're trying to work around these issues, and yes, sometimes we find other solutions, and it's great when you go to a different control system platform or replacing other components. On our last piece of equipment we're building right now at the moment, we actually had 18 electrical redesigns because we could not find components. We had to redesign things. We went to purchasing, try to buy stuff. Nope, not available either. Try again. And we just kept going. So we actually have to find, like what you say, a completely new way how we're going to source equipment. It used to be electrical design tells us what they need. Purchasing goes out and gets the stuff. Now it's like, no, they have to work differently. Purchasing now needs to tell them what you can get, and you need to build your design around that basically nowadays. How are we going to solve this? That was the other part of your question. Our colleagues over here sitting here today, I would like to post it to them actually, because we really don't, what we've seen is, we've seen a lot of different supply issues in different areas. You can't even pinpoint what it is nowadays. We have actually even had to redesign certain mechanical design aspects of our machines because certain material dimensions were no longer available. Who ever heard of this before? Like, it's been something in the past, we've never ever had to go to a metal supplier and say, can you find this material in the States or in Europe or somewhere and bring it in? If not, then we have to redesign parts of our machine. That's really how bad it is right now at the moment. I do hope that this will not be lasting for much, much longer because I really don't know how we can deliver anything anymore. But it is still, I still see this at least going for another half a year or maybe hopefully another year. There's a little bit of a hope that I'm having is that as much as a recession is not a good thing, we are all so extremely busy right now at the moment in automation and robotics that a little bit of a slowdown may not be the worst thing. Just to get supply chains back in order again, to get everything back aligned a little bit, have supplies build up again, and then start again from scratch. I think if we do go into a small recession, it should not last for too long because the demand really is there. We just cannot supply anything. I think that's what causing the big supply issue.
Well, and I'm glad that the cash flow piece is something people don't think about because, you know, we ordered 50 components for to automate some spraying equipment for a customer, for a large customer out of the US. And so those components, which I started ordering in October of last year, are finally starting to arrive. And so that, you know, I still have to pay all the employees, all the technicians, all the office space, all these kinds of things. And, you know, and then as the components are shipping, you know, they're looking for payment, right? And so suddenly this turns into a year-long delay. When you look at the robotic manufacturers in the agricultural space, a lot of them are startup entrepreneurs and they don't have, they don't have that. They don't have that backing. And so they're relying on, you know, investor money and you know, angel investors and this type of stuff. And so they can't build their inventory, you know. So if you're a company that wants to get out of the valley of death and move into into sales, and you can't build your product and sell it, it must be terrifying for them.
What a fantastic discussion on robotics. This is a topic that could easily be a true rabbit hole that we could go down for hours. I know you're ready to do that. You have given us a lot to consider, and I'm sure there are a lot of many wheels turning for those in the audience. We have a few minutes for Q&A, so please feel free to add your questions in the Q&A feature online. Or in this room, if you have a question, please shoot up your hand and we'll let you get to it. Okay. Should I just move the mic there? Okay.
Very interesting discussion. Thank you very much, gentlemen. The subject of safety came up and legislation came up. So I'm wondering what the role of government has. Are they a hindrance? Are they, I get you, but are they are there doorkeepers? Are they, you know, blocking you? How much do we need them or not need them?
Well, somebody needs to be the quarterback. At the end of the day, someone has to be the bad cop. And I think the only role that I would see, or the role that I would like to see from the government, would be someone for them to quarterback and say, let's have a meeting. You know, I don't know that the government knows enough to actually make any regulations. But I think in the ag space, I think if they could quarterback and say, let's have a meeting and amongst the manufacturers, that would be good. I know like kind of what you talked about. And, you know, we are looking very much at the industrial side, you know, like the autonomous forklifts, you know, that could, you know, robots in factories. A lot of those rules and regulations are going to translate into the ag space. And there's lots of reasons why they should. But I think as from a quarterback role will be a good one.
Yeah, I'm going to make a call to one of my friends on the safety committee for the on the collaborative robot space, because they have a model that I think works. And, you know, government's great for doing certain things. I think this is one of those things that it's not great for. I think if industry can take the bull by the horns, it makes so much more sense because they're so close to the tech. And it's not like it hasn't been done already before, right? We have an autonomous robot is a robot that actually wheels itself around. And collaborative robots are robots that work with humans. And so I think we're getting really, really close. And I don't think we have to reinvent the wheel.
Not sure.
Thank you for the great talk. I'm just wondering what kind of marketing strategies have you found that work most effectively? Like how do you get new customers?
Working with Jim. That's the best solution. No, I mean, we are still a relatively small company, but we trying to promote a lot to our environment, to our systems that we know. Companies who we're working with, typically we find we have good recommendations of other manufacturers. And at the moment, we don't do too much marketing, actually, quite honestly, because we don't have the capacity to build much more at the moment. But once we have the products established and have more of an ongoing product, then we will be facing much more into marketing side of it. But in the custom automation industry, it's difficult. You end up marketing business to business, but you also need to find very specific customers that you can speak to. And so broad marketing, I find, is not a big aspect, but more tailored and dedicated marketing. But Jim, you're probably better off to speak on that one.
So in the kind of factory automation and robots integration business in the OEM, we're doing a lot of work in communication. So doing a lot of work in webinars. I have a podcast, do a lot of work in blogging, trade event marketing. Still, if you're into broad, that works well. But also a lot of the robot companies, a lot of the companies that build automation will use their existing base to actually communicate to, because there's nothing better than having a customer's bought automation for you for 10 years. They'll keep buying automation for you as long as you don't screw up too much, because it is a very complicated business. And in the robot automation and especially machine business, your customer does kind of not like you for a little while sometimes when you deliver that machine, because maybe it doesn't work 100%, and it takes 6 months. But I think communication is really the key, and using tools like YouTube and blogging and trade event, if it works for you, those are all really, really good ways to market.
I think what I've seen with the companies that are more successful than others are the ones who do one thing and they do it well. Focus, and I make sure your robot drives straight. Start with that. Don't worry about all the sensors and everything else it does. Make sure it drives straight. So do one thing and do it well, and then communicate that I am solving this task. This is what we do. And social media and YouTube videos, those are all good things for backup, but the reality, nothing beats the customers need to see it. They need to see it in action, either at a customer's site or at a demonstration site or whatever. The customers need to see that thing in the real world. Oh, for sure it is. In agriculture, very much so. If you can't kick that tire, you're dead in the water.
Great. Did you have one?
Thank you very much, guys. I've worked as a tool designer for a nuclear services company, and so they've basically definition of custom robots. What a difficulty that I found and the team that I worked with found was balancing the electronic and the mechanical systems. So it's all well and good to have an idea to take something that's like manually driven with G code, for example, and then turn that into a more automated task where you're incorporating sensors and automatic loops and everything. And so I guess I'm wondering what's your approach specifically for developing the prototypes that can also do, say, production tasks, but changing from the mechanical design approaches to a more electrical and some of the challenges that come with that kind of change in thinking.
That's a very interesting and complex question. Obviously, not knowing more in detail, it's somewhat difficult. The one thing that we've been doing is we've been thinking about our systems. How can we standardize them to fit to many different applications? How would a system have to look like that we don't have to build each system individually, just dedicated for one product. And so we kind of took those commonalities away. And then what we did is we kind of built, even now when we're prototyping something, we have a standard platform that we're using. We may do some handling on that platform, for example. And that platform is usually driven without any tooling or any specialty tooling, or without any pneumatics, for example. We use all just electric motors and controls for that. So we can actually position everything and run all the motions from there. Now you could use robots, and quite often people use robots for that. And that's why actually industrial robots have become so popular, because you can use them, retool them, or reprogram them if your part changes slightly. And you're not so dedicated like a dedicated machine tool, which is always difficult to change. But robots sometimes are a little bit, they're just one tool basically. You don't need always the 6 axes for that. The prototyping becomes really the essence to find a way how to do that in order to, then of course, if you can use that same prototype now to actually develop your whole machine out of this, to implement more functionality to that same system, then it's even easier basically. But it all comes down to having a good base system that is modular enough that it can handle those aspects.
I think from the ag side, when we moved from a mechanical machine to something that is now electronic, like there's more and more electronics and sensors. If you think about a corn planter that was built in 1970s, was fully mechanical, little springs and fingers. And now they're all electric drive, little 12-volt DC motors. The focus has to be on, can I make this more reliable than the old system? And if you can't make it more reliable, then don't do it. I think there's sometimes, if something isn't broke, I guess don't fix it might be a good answer, but reliability is key. And then also being able to track what that machine is doing, on a regular basis. And I think about, so we have most of our sprayers, for example, have been automated. So all the rate control is automatic and all these types of things. It's all done with electronic components. But the key has been to make that as reliable, and then also to track what is being applied where. And that will convince the person that it's worth it, to take that step. I don't know whether we're going and answering your question or not, but I think that's okay.
Great. Well, thank you very much. It looks like it's about that time to conclude today's fireside chat. Again, a huge thank you to Jim, Chuck, and Konrad for sharing your expertise on such a fascinating, impactful, and revolutionary industry that can and does truly impact many thriving ventures contributing to our innovation economy. Knowledge is power, and today we were privy to some important and fascinating current and future robotics industry trends. On behalf of Tech Alliance, thank you for joining us. We've loved having you with us today, whether it be virtual or in person. Be sure to check out all of our upcoming events on our events page, and especially don't miss the chance to connect and bring in the season at our holiday mixer, Jingle and Mingle, on December 13th. It's always our aim to keep you connected to the exciting world of regional innovation and technology and those that are making it all happen. So thank you very much. Stay safe, be well, and take good care of yourself and each other.